be streaming. Alright. Let's just check we're just chill. Okay, I guess we'll just do some problems. Okay, so we have to convert decimal to binary. So we have the indexes that we need to index into. So, as we see here, because, wait, what's 10 in binary? What's in binary? Yes, 10, 1, 0, 1, 0. So here, right, 0, 1, 2, 3, right? That's exactly what we have. Right now we have the list of where we need to put the ones and zeros. So what we can do is well, we have 3 and we always have the higher number there, so we can just add a quick for, maybe this isn't the most efficient way, but we can put let's say for I in range, and we're doing out dot 0, right? So we're doing it for I in range there. So that's 0, 1, 2, 3. So that's going to index over 4 numbers, right? Oh, what we could do is I think it's called insert 0. So, well, maybe sec. I think it's called insert to put at this front. Or is it dot push? No, maybe. Yeah, dot insert 0, 0. Yeah, okay. So so let's create a new list of columns. All right. Okay. Yeah. So right here, we need to, for I in range, output 0. So we're doing from 0 to 3, right? 0, 1, 2, 3. 0, 1, 2, 3. Right. We need to, if I in, if the index is in out, right? Then we need to do output dot insert 0, comma 1, else output dot insert 0, comma 1. Sorry, 0, comma 0. Right, so now we have the output. So this should be the, oh, we spelled insert wrong. Boom. So now we should have the output. Yeah, we have the output here. So now we have to talk about, so we want to have that's binary. We want to output it as a, do we want to output it? Check real quick. Do we want to output as a string? Oh, we want to output as a string. Did we do that last time for our other functions? Oops. Apparently we're supposed to output as a string. Misread that. But we can just add a string marker here, so it just turns into a string. Not too bad. We just don't have to recode anything. Just add a little bit of code. Okay. Yeah, so anyway, it'll insert, that means that it'll insert 0 at position 0. So it'll, at the start, it'll add a 0. And now we should have a list with basically the numbers 10010 or however it should be. So now we need to do so we need to return and join. So we need to join all the all the all the stuff that's in the list, and we need to what list do we need to join? We need to do string s for s in output. All right, so let's just try this out. Let's see if we can turn a decimal into a binary. Well, we already have the test right here, but we should write a tests file. Oh yeah, so the problem is it's a list there, so we need to make it an integer. So we need to do that. And oh, the mistake is actually over here, so we shouldn't be doing this. That creates a separate list. We don't even need to do this integer here. Remove that because it's creating a, as you see it in this here, it's each of these objects is a list inside another list. But instead we could just do 3, 1, keep it simpler. So let's try this. Okay, so it's obviously not correct. Let's try running it one more time. Okay, 010. So let's check the established result, what it should be. 1010. Right. Huh. Let's just do. I'm just gonna try this. I don't. Let's just try this. Yep. The reason this works is because so output should be 3, right? So okay. So the reason this works is because output, let's say, is 3, right? So you need the numbers 0, 1, 2, 3. But in Python, if you put if you put in range 3, it'll put 0, 1, 2. So you need to add 1 for it in order to actually be the number you want to be. Which is this. So I guess we could do the next question if we want. Decimal to binary is pretty easy. Decimal to now we're doing decimal to hexadecimal. Um, yeah, so this is pretty easy. So let's do decimal to hexadecimal. The tough part about this is so let's just copy the code in for a second. And obviously this won't work for now. But let's just keep this code in for a second. Okay. So what we would need to change, first of all, this 2 should be 16, right? And this should also be 16 right here. That'll also cause some nice fun bugs. And okay, so this can't be just insert 0 or 1. Actually, yeah, it can be. Oh, I think we might need to evaluate some of the stuff here. Okay, wait. So we have so we have, the way we do it here is kind of interesting. Okay, so let's just, so we have the appended the indexes, but we should also append the, should we? Wait. What stops us from just using the same formula? Okay, right. So the largest power is 16. Oh, I think we might need to a little bit reevaluate this code. because there's multiple numbers here. Oh wait, instead of just subtracting the last number, we need to try each number again. So instead of doing this, we need to have a separate for loop. So for, let's just do in range string, but it could get pretty big, fortunately. I don't think it should be in range string, but okay, let's just do it for now, I guess. So, times I, because, okay, wait. So, I don't know if this is the most efficient way of doing it, but, okay, so what we can calculate is, so we can say that this is equal to, so let's just say val is equal, this is like really ugly code, I think, fortunately. So, what we're gonna do is we're gonna set val equal to last name times I, and, if string minus last num times I is less than 0, or is it's not greater than 0. How you do it? Oh. It's, I think, less than 0. Let's just go with that. Or is it? That's right. I think that's right. It's fine. We'll figure it out when we run anyway. Basically, if the string is less than or equal to 0, whoa, okay, wait, we're just gonna cut this code out, Alright, okay. Okay, I think after this one, we're just gonna skip below the rest of the exercises. A little bit kind of boring just to be doing binary to hexadecimals, because I just want to go on to the next part. What is the next part? Speaking of cursive sequences, just want to go through that. Decimal to binary is easy. But the reason is you have to know, basically in thing, you have to know these coefficients. This coefficients is all that matters, right? So when you're given a number, you have to first find, okay, 16 to the power 4 is the biggest. To find the coefficient, then you have to find an array of all the coefficients. Yeah. Right, so here's how we did it in binary. But that won't really cut it. We'll need a second loop. So when we have this, right? Yeah, we were on the right track, but it's good to get a little bit grounded. So we don't need out. Out is just not needed. This is not needed. What we do need though. Never mind, out is needed. But what's also needed is val. Oh, sorry, coefficients maybe? Coefficient. So yeah, coefficients is there. So let's put another for loop, I guess. For I in range. Let's do range string again. Or that's a little bit of a long loop, unnecessarily long, I think, but we could even do. I don't know, maybe it could be, but or the maximum it could be was 16, right? So we'll just do 16, right? Because the maximum it could be was it would be 16. Good thinking there, but okay. So basically, we just try basically just create a val. Just create val equals none, and what we can do is we can do So first we need to break if we need a break condition. So we need to say if sorry, if string minus I times here. Okay, so what are we doing inside string? So we're looking at string is minus a number times. Oh, why are we doing I? We could just do times last num, where last num is a value that we've calculated. Oops, sorry, last num. Yeah, cool. So if it's greater than 0, we just break. Ah, dang. Try break, right? But else, if it's not, then we just continue. But we also need to update val. So what is val going to be? Val is going to be equal to this number right here, last num times I. So let's just copy that in. So now we're storing the vals. So let's just do vals dot append, or is it vals or coefficients? Sorry, coefficients. I spelled that wrong. Just come back. Cool. So we have the coefficients, we have the values. So I think we should be good, but let's just do a quick test run where it returns return out, comma, coefficients. Right. So and this is for so let's do a quick test run. So let's do print decimal to hexadecimal. And we're doing it we need two lists. Or sorry, not two lists. We need a number. Oh, why did I Oh, oops. See daisy? Put a string there. Also takes input. So now we need to let's put what number did they put in this example? Let's do 24. So 9091. So we have a comparison for a quick comparison. Okay, cool. Let's put that in. Let's just run it. Let's see what we get. Okay. Not very. Whoa. Okay. Not very good at all. Not very good at all. Very disappointing. Because 24 it returns 17 comma none. It should be returning 4 there, but it's kind of weird. I think something messes up the loop here. Okay, so how about this? So first, we'll have it return outcome coefficients. This is basically just the binary code, I believe. Oh! Oh, we forgot to replace this with 16. Oh, wait, Control Z. Just Control Z everything. Yeah, okay, so adding 10 or whatever number. What's the number? Yeah, there. Okay, but this is the reason. Like, we forgot to replace this with 16. It's hexadecimal, not decimal. I mean, not decimal, not binary. Oops. Okay, so let's test this out now. Maybe this will be... Okay, so this 4 is being returned, which is good. Right, that's a little bit of progress. This is still none, so that's not too good. So, hmm. Uh, hmm. Oh, I think I know why it's wrong. We didn't update string. So we should have done what we should have done is at the end of this, we should have done right before we end, we should have done string equals minus equals val. Right? So maybe that should fix it. Let's check out that. Ooh, an untype. Okay, so val is just not being updated at all. Huh. It's just breaking immediately? Well, if it is, let's just add a print statement here. Let's just do a print debug. I think I need to like go back, reevaluate each line of code. So it is printing. So okay, so this is just being triggered immediately. Um, so quickly, so print last num. So it should be 65,000. Okay, cool. So that's being evaluated, right? Right. So it's 65,546. So we're setting this to none. Um. What? Um. So let's just create a variable for the last num times I. Um. Oops. Just put that in there. So let's just put in num here. Um. So that's just to show the current number. So it's still a none type. So it's not being set here. So let's print num. So we get an idea of how many times. So it shouldn't print in range 16 if what we think is happening is happening. So 0, right? So string minus is greater than 0. Um, oh, oh. Oops, oopsie daisy. It's supposed to be. We switched the signs. Um, move this print statement. Oh, val is supposed to be I. Or, wait, val is going to be 3 times 16 to the power of 4. Right? Right. So we just do this. Um, so let's test this out. Okay, so 4310. So let's just check this. Um, okay, so 4, 3. There's no 2, but there is a 1 and there is a 0. Okay, so that's very good. It's very good. So now let's print let's return the sum, the coefficients. Pretty sure you're not supposed to use any outside libraries, but I think sum is probably fine. Oh, yes! Yes! Alright, we did it. Decimal to hexadecimal. Okay, that shouldn't have taken that long, but okay. So we're just supposed to return this. So let's just return this. Okay, yeah. So that took a lot longer than we needed to do. And this is kind of unnecessary. We don't even need out. Do we? No, we don't. Right? Let's just check. Let's check one more time. Make sure. Whoa, there's some problem. Exercises up by. Unused variable is fine. Yeah, I'll remove that. So yeah, it's kind of cool. We didn't even need it after all. Let's check the thing. Where's the unused variable? Oh, okay. We don't even need the last index anymore because we can just do it without it. It's a lot cleaner code, I think. And there's trailing white space. Oh yeah, okay, just fix that. No white space. You don't want that. Okay, lint. I wish I could get rid of the linting for this, but yeah, it's pretty cool, pretty decent code, I'd say. Not the most beautiful. Like, I'm sure there's a way to optimize it. Like, I don't think you need to go in range string, but okay. So binary to hexadecimal is pretty easy. Should we make tests for this? We could, like, how we ran tests for this. You run tests so you could check all your codes right, but I guess, but um, I wish I could. It's kind of hard for you guys to see, but anyway, let's do binary to hexadecimal. So binary. Oh, you know what? I don't want to type this out. Let's just bada bing. Oops. Yep, and okay. So we're doing binary to hexadecimal. Well, we already have binary to decimal and decimal to hexadecimal. So what we do is we take the string. Uh, we're supposed to return a string, so let's quickly just stringify it. Okay, cool. So what we do is string. Alright, so what we do is string. So okay, so what we do is binary to decimal of string. And then this is a decimal value, and then we do decimal to hexadecimal. So it's boom and should be boom. We should be able to return the values of this. So let's just do a quick test. Print bad indentation. Why is that bad? Wants me to put a doc string. Okay. Binary to this is why I normally disable linter, I think. It's probably better for general readability. What does this even mean? Final. Dude, it's fine. I don't know what it's even saying. Can't even read it. It's so like small. So yeah, it's fine. It's probably nothing. Um. Okay, let's just do this. So let's do a quick test here. So let's do. Um. Okay. Okay, binary to hexadecimal. That is a string. Whoa, 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 whoa. I think I did something wrong. Oh wait, we did our hexadecimal wrong. Yeah, we did decimal to hexadecimal wrong. We have to we have the coefficients, but we have to translate them into. Oh, that's why I needed the coefficients, not just the number. Oh, so stupid. And instead of appending val, I should be appending. Oh, man. Dude, I thought I got it for a second, and I was like, no, I don't. Okay. So, oops. So let's say idx is equal to I. So we should have the index now. Instead of we should append I. So let's just do return coefficients. Just quickly. So just do some quick debugging. Oh, sorry, not for that. We should do something easier. Let's just do a quick print. Realize we made a mistake. This is why you should probably be texting all your code before you start using it in other places. Good thing we at least found it out. So let's just do, what, yes, decimal number. 412. Oh. Sorry, 412, 18, 15. This is all off by one error. Don't do that. What am I doing? No, there's some error and I'm not sure where. 15, 8. Oh. Why am I appending I? Bro, alright. Yeah, but that's the coefficient, but you need to make sure of, along with the coefficients, let's just make sure that the out. Oh no, needed out. Now I realize why I needed out, didn't I? Yo, what was I doing, bro? Bro, I converted the decimal values back into a decimal. Like, I found the decimal values, managed to do a complicated way to convert them back into decimals, basically. That's basically what I did. So we need to store, oh, so, okay, so we need to store I. So we know where to insert these. So wherever there's nothing, it's just a 0. Um, so yeah, so we have this. I. So let's just store that as I. So we can probably do out.append last idx. I'm actually tripping today. Not coding particularly well. Oh, I thought I put I. Of course I do. No, okay, we'll go back here. So let's return coefficients, comma, out. Let's try to make sure we didn't put an error there. Alright, so that returns 4310. Okay, cool. Cool. So now we have coefficients and we have the out values. Right, so now we just need the easy part, conversion. I believe we have like a big hexadecimal to decimal. We have this. Unfortunately, when you convert decimal, I think you have to have one of these hash map types. This is H2Y. This is hexadecimal to decimal. So you have to make that basically I to H. So let's say that's equals I to H. This. Let's say it's equal to K comma V for K comma V in, or sorry, V comma K. So what are we doing it in? It's H2I items, so that there's there's this, wait, let's go back. Yeah, items, I think, believes returns the list with sublists of key value pairs. So once we have this ito thing, it's not too difficult. At least I hope. So can we add two strings together? Yeah, you can. Oh, right. No, I feel like I'm tripping. Okay, so let's just do that real quick. Just trying to make sure. So val equals bass equals super weird. Random val. Oh, sorry. Print val plus bass. Yeah. Okay. Cool. Oh, you just add strings. Yeah. So I can't believe I forgot you could add strings. I really be cooked here. But okay. So it's pretty simple. So for I in range, so let's do out, and we want the first range in out, right? So we'll have out is just going to be 4310. So it's going to be out plus one, obviously, because you want the numbers 0, 1, 2, 3, 4. That's all the numbers you want. Right. So if I in out, then let's just write the else really quickly first. So else, we take output. Let's just add an output thing. Oh, not output. We've already done that. Oh no, output. Yeah. Well, boom. So output plus equals. So let's add a 0, right? We add a 0. But if it is an out, right? Then that number. Let's say it's. Let's imagine we're indexing through it. Right, so we're at 0. So 0 is an out. It's right here. 1 is also an out. So let's take with 0, right? If 0 is an out, we need to find the value that 15 has an out. I mean, just sum that. There's a way to do this, but it's kind of unelegant, I think. This is like really inefficient, I think. You do it with the index where you put the array, but maybe there's a more efficient way to do it. Do this instead of if I'm range out, you do if I'm range. You're checking. You want to see if it's an out. You your computer's kind of slow, so it's fine. Okay. Huh.